All right, guys. Hope everyone's been doing well. We don't have any exams this year. I gave you guys, a week or so here. I updated all the grades. Gave you guys a week to make up any work that you've been missing. I did have a few questions from people on email that I just got to recently. If I haven't gotten back to you on that, I will do that shortly. Again, it really does help if you guys join in on the Zooms. I will do a Zoom tomorrow. All right, at 11 a.m. if you have any questions about anything that's going on with the grade book, etc. Okay, that is tomorrow, Tuesday, June 2nd, all right, at 11 a.m. So we're going to go ahead and get going with this lesson. It'll be short and sweet today, all right, as we get back into the things. We're going to go up to the day that school ends, fellas. So, again, we don't have exams. So the way that we're going to do this is I am going to post a few lessons a week so that you guys can continue to work on your math, so that we can continue to cover things that we would have been covering, if this pandemic hadn't occurred. All right, so let's look at this, all right, right at the beginning here. All right, so a to the 1 over n power. So this is an exponent, okay? So let's read this. It says expressions with rational exponents can be rewritten as radicals using the following rules. All right, so a standing for any number, okay? So if we have a number that's the base, all right, a is the base here, and then this 1 over n is the exponent. So what does that mean, right? It means the nth root of a. So where's that n coming from, right? The nth root of a. All right, so in other words, what this means is a to the 1 over n. Now I'm right here, okay, I'm going to fill this in. A to the 1 over n is the same as the nth root of a. All right, so where's this 1, right? That 1 is actually going to be right there, right? But we don't need to write the first power, okay? So where's this n right here, right? That is going to be the root, all right? That is going to be our root. So in this case, it's the nth root, but if that were a 3, this would be a cube root, right? If that were a 2, it would be a square root, all right? And again, it's a to the first power because of the 1 there, all right? Let's move on. All right, so based on what we just learned there, this one should be no problem, all right? A to the m over n is a. All right, there's our a. And again, n is our denominator, right? So that means it is an nth root. And m is our numerator in the exponent, so that means it is going to be our power, right? It's our power. So this is the nth root of a to the mth power, okay? So what we're going to do today, I'm going to go through these. We have, as you can see, 18 problems here, all right? I'm going to go through the odds and ask you guys to do the evens, post the notes and your work to Google Classrooms. All right, so let's go ahead and get this going. All right, and all we're doing is just converting it, all right, and simplifying it when we can. All right, so first one. X to the 1 over 4 is going to equal the fourth root of x to the first power, right? The fourth root of x to the first power, or just x. We don't really need to write that, right? We don't really need to write that, all right? So because the denominator is 4, all right, what that really means is this. Now, why? Let me ask this question, why are we actually doing this? Why do we have to write the expression in radical form? Well, it's really, unless we're just doing math with it, it's really tough to understand what this means, right? You can see how it does translate. So we need to transfer it into the other form in order to simplify the radical itself, okay? It will come into play later, all right? It will definitely come into play. Let's go to 3 now, all right? Maybe I'll mess up and accidentally do an even here. Hopefully not. We'll see. All right, so 24 to the 1 over 3 power, all right? So 1, right, on the numerator. What's the numerator? The numerator is going to be the power of the number that's inside of our radicand, right? So let's go ahead and see what we got here, right? And the 3 is, of course, going to be the root itself. So this is a cube root, all right? So this equals the cube root because 3 is the denominator of the exponent, so that makes it a cube root immediately, all right? Next, 24, the base here remains our base. It's our radicand, all right? So we're going to go ahead and put that inside. And what is the exponent? Oops, sorry about that. What is the exponent? The exponent is 1 over 3, and the numerator is 1, so this is 24 to the first power. or just 24, right? Now, are we done with this? No, I probably should have written this a little bit smaller, right? But do we have any cube roots inside of the cube root of 24? We do. 8, all right, times 3 is 24, so the cube root of 8 times the cube root of 3. All right, now we can simplify the cube root of 8. 2 times 2 times 2. All right, so this ends up being 2 cube root of 3. All right, 2 cube root of 3 based on our simplification, which we've done a lot of. All right, k to the 7 over 2. K to the 7 over 2 here. So we are going to have to simplify this one, so let's go ahead and do this. This is going to equal, I'm going to put this over here, and since we're going to need some space here. So this is a square root. Do I need to write the 2 up here? I don't, right? I don't need to write the 2 because it's a square root. By not having it there, we know it's a square root, all right? So this would be k to the 7th, all right? Now, again, how do we simplify exponents, right? Radicants that have exponents here, all right? Well, we can, again, figure out which k to the what is a perfect square. K to the 2nd is a perfect square. K to the 4th is a perfect square, right? Also fits inside of here. But k to the 6th, any even exponent, is a perfect square. So what we're going to do is we're going to make this equal to, I'll do this in different colors so that you guys can see the layers here, equals the square root of k to the 6th times square root of k to the 1st, or just k, right? And what is the square root of k to the 6th? The square root of k to the 6th is, well, we just divide, since this is a 2 here, right, we just divide by 2, all right, so 6 divided by 2 gives us 3. So this is k to the 3rd times the square root of k, and that's as simplified as we can get here. All right, so hopefully you saw what we did there. All right, put it in the square root first, and then simplified the variable exponent. All right. The radical with the variable exponent. Okay, so number 7 here, all right? We have a, b. Now, notice that it is in parentheses, okay? It's in parentheses. That means that is our entire base. If this was a, right, b, 3 to the 4th power, would be a little bit different here, right? But since that we have those 2 parentheses there, and I'm doing all kinds of hand motions right now. It's very difficult for me to explain things without being in person sometimes, so I'm going to try to stop the hand motions. It doesn't make sense doing those. But having those parentheses there means that this power is going to this entire thing, the whole thing that's in parentheses, okay? So that is going to go inside of our 4th root. So here we go. This equals the 4th root of, and now look, here's what we have to do. And this is like where it gets a little bit tricky. You see how, as well as talking about with the parentheses, a, b to the 3rd power. That whole thing is to the 3rd power, okay? Again, if this was a b, if that wasn't there, right, that b would only have the 3rd power with it there, okay? So, and the a would be outside of it. That's a lot to explain, but we'll get there eventually, all right? We're actually going to see that with number 9, so that's perfect. Okay, so a, b to the 3rd power here. All right, now what do we have to do to simplify this? We just need to use our, I'm sorry, I'm getting another color here. We just need to use our exponent rules and distribute that 3 to both, right there, to the a and to the b. So what this will look like is this will end up equaling the square root of, the 4th root of a to the 3rd, b to the 3rd. Now, can this be simplified? No. Right? If these were 4th powers or bigger, right, then we would be able to simplify it because this is a 4th power, but it's too small to simplify, so that is our final answer there. The 4th root of a to the 3rd, b to the 3rd. All right? Next, number 9. So remember what I said about these parentheses. Because these parentheses right here, right, that I'm pointing at, right, are associated with this, right, this 7 is not a part of it. This 7 is going to be hanging out on the outside, all right? So let's go ahead and get this started. I'll get rid of those. This is going to be 7 on the outside. I'm going to write this over here first to start so we have space. I've apologized numerous times about not having enough space on this. If this somehow goes into next year, I'm going to try to find something that allows me to zoom a little bit here. All right, so we got 12W on the inside. Now, where's the 1 and the 2? Right. Well, again, hopefully you guys have been following along, the 2's here and the 1 is technically around both of these, right? But we don't need to write that there because it's to the first power. We've never had to do that, right? We understand why. All right, so here we go. Are there any perfect squares inside of 12, right? 2 times 6 is 2 a perfect square? No. Is 6 a perfect square? No. Okay. Is 4 a perfect square? 4 times 3? Yes, 4 is a perfect square. Here we go. All right, so here's what we got. We have this equals 7. Now, is W a perfect square? No. Okay, W is not a perfect square. So what we're going to do is this. 7, right, on the outside, square root of 4, times the square root of 3, W. We're going to keep that W with the non-perfect square since it isn't a perfect square. Okay? 7 to the square root of 4. What is the square root of 4? The square root of 4 is 2. Right? So this is 7 times 2. Right? This is 7 times 2. All right, so I don't have a lot of space here, so I would write that. All right, that this is 7 times 2 because the square root of 4 is 2. What is 7 times 2? It is 14. Square root of 3W. All right, and that is our final answer. We cannot do any more simplification. All right, last few that we have here, and the rest will be up to you. Again, join in the Zoom meeting tomorrow. All right, June 2nd, 11 a.m. I will put on there if there's any changes to that, but it should, again, just a 30-minute review if you guys need it to log on to Zoom. All right, so this is asking us to reverse what we just did, all right, and write it in exponential form. So what we were doing before is we had it in exponential form, and then we were writing it in radical form. Here, we're going to take it from radical form and write it in exponential form. All right, so again, I'm going to have you guys do the evens, so I'm going to start with number 11. We have xy, right? Now, that whole thing is inside of the square root, so because there's two numbers there, right, or two variables, x and y, we're going to need a parentheses, all right? So what kind of root is this? It's a square root. That is our denominator. And what is the exponent, right? The exponent out here, if we had parentheses there, it would just be a 1, right? Because we don't see one. So here we go. This is going to be parentheses xy to the 1/2 or 1/2 power, all right? Again, think about what we just did. We're just doing the complete reverse of that, all right? So pretty quickly, we should be able to start looking at this and seeing what's going on here. 11 is our base, all right? So I'm going to make that our base, and I'll do this in some color for you so it makes it a little bit easier to see. 11's our base there, all right? 2 is our exponent, so where does that go? The exponent inside goes on our numerator, right? Whoops, didn't use the different color like I said. So the 2, boom, it's our numerator, okay? And that's over. What's our denominator? It's what the root is. There's the root, so our denominator is 3. So it's 11 to the 2/3. All right? And if you want to put that 11 in parentheses, that's fine as well. All right, next one. 15. We have 2 more to go. The square root of 3m with 7 on the outside there, right? To the 7th power. All right, square root of 3 times m to the 7th power. All right, so what are we going to do here? Well, the reason that 7 is on the outside is because it's letting us know, again, that that is associated with the 3m inside. Okay, so the way that we're going to write this, it's a square root, right? So that 2 makes it our denominator. So this is 3m to the 7/2 power. But the only thing I'm missing is the parentheses. It goes around the whole thing there. All right? You can tell that because of the parentheses that are right here. Okay? Next, number 17, we have the square root of 10 to the 5th, a to the 3rd, b to the 1st. All right? Now, there is, again, not really we don't see the parentheses with the exponent on the outside. Is there an exponent, though, on the outside? Yeah, there is, technically, right? There is a 1 out here. Right? So that is what is going to end up being our numerator. Here, we could see what our numerator was, right? For number 15, if you just see, I just circled that up at number 15. See that 7, right? We knew that was going to be there. Here, right, if we were looking at number 17, right? I don't see that number out here, right? Now, what does that mean? Does it mean that number is 0? No, it means that that number is 1, because technically this is a 1 on the outside. So 1 is going to be our numerator, right? What kind of root is it? It's a square root. 2 will be our denominator, and our base is the entire thing that's inside. So 10 to the 5th, a to the 3rd, b. All right, so we're going to go ahead and write that. 10 to the 5th, a to the 3rd, b. All right, and I'm going to put all of that. It has to all be in parentheses, since this entire thing is inside of the square root there, right? You see it's all inside the square root, so it has to be in parentheses, and this is to the 1/2 power. Okay? That's it. Get this done, fellas. Good luck. If you want to log into the Zoom meeting at 11 a.m. tomorrow to check in, that would be great. Looking forward to seeing and hearing from you. I'll give you guys some time to make some things up if you didn't use that time to make up assignments. We're getting down to the end. Listen, fellas, if you turn the assignments in, I can get a grade for you, okay? So make sure that you're getting those assignments in. I had a few guys, after I updated the grade book, they did turn some things in. So that was going into the weekend. I will get those things graded and back to you shortly. All right. Hope you guys are doing well. We'll look forward to seeing some of you guys tomorrow as you check in. All right. Bye.